We are here together talking about function families. We're going to talk about linear today, and we're going to do some graphing, and I want you to notice some specific things that happen. If you've not already done this on your Chromebook, I highly recommend that you go to your search engine and put in desmos.com and look for a graphing calculator. So I would bookmark it once you're done, and the bookmark is just by doing the star, and it shows up here. There is a scientific one, but you're going to need the graphing one for this chapter. So I would go ahead and bookmark it. All right. So we're going to do some linear. We're going to talk about linear, which is a line. Y equals mx plus b is the standard form, and it makes a straight line. If I were to do 1y equals negative 2x plus 5, say, you can see that this graphed my line for me. That's why it's so nice to have this graphing calculator. This first part here is the y-intercept. So the y-intercept starts at 5. It crosses the y-axis, y-intercept. It intersects the y-axis at 5. And then the slope right here is the coefficient on the x. It goes down 2. It's a negative 2, meaning you go down 2, 1, 2, and over 1. Down 1, 2, and over 1. Down 1, 2, and over 1. And you can keep going like that. So where we've been plotting points, you could actually just draw this in with starting with your y-intercept and then going down 2. Now, this happens to have a negative slope. When I write the word negative in there, it kind of takes it away, but that's okay. I'm going to go through a few of them. My next one I want to graph. Put in your graphing calculator. F of x equals 7x minus 2. So this means you're going to start at negative 2 on the y-intercept. Here it is. And this time, the slope, the coefficient on the x term, is 7. So that means it goes up 7. 1, 2, 3, 4, 5, 6, 7, and over 1. And then I could count again. 1, 2, 3, 4, 5, 6, 7, and over 1. Now, I know these numbers on the axes are not the same. They're just trying to show you all of them, but you could see that little grid underneath, and those are actually 7 boxes and over 1. This is said to have a positive slope. Let's graph another. Let's do another. F of x, again, means the same thing as y, equals 0.25x, which would mean 1/4 plus 1. So as you graph this one, it starts on the y-axis at 1, and then you're going to go 1/4, which 0.25 is 1/4. So thinking in terms of 1/4, that means you're going to go up 1 box and over 1, 2, 3, 4. Up 1 box, over 1, 2, 3, 4. And again, ignore these numbers here on the axes. Just think of in terms of boxes as you're counting. Up 1 over 4, up 1 over 4. And this one is also a positive slope. Now, what I want you to do is I want you to think about all 3 of these together. So I'm going to erase this negative. There's that first one again. Notice that it's blue here and it's a blue line. I'm going to erase this positive, and notice it's a green line, and that's that green line here. And then over here, I'm going to erase this, and now it has purple, and it's a purple line. Now, when the slope, it doesn't matter if it's positive or negative, but the bigger the number on the slope, again, it does not matter if it's positive or negative. It's like absolute value. When it's a bigger number, you notice it's a steeper line. When it's a smaller number, this is fraction 1/4, it's less steep. Let me do one more really quick. Y equals 0.125x minus 5. Now, of course, this went through the y-axis at negative 5. This means 0.125 would be 1/8. So if you counted boxes again, you'd go up 1 and over 8. 1, 2, 3, 4, 5, 6, 7, and 8. And there you ran into the next line. And look at how it's not very steep at all. It's almost horizontal. So what I want you to realize is the higher the slope, the number before the x, the steeper the line. The smaller, the less steep. All right.